Thank you very much. So I'm Gilad Channer. I'm responsible for HPC marketing at Mellanox. I joined Mellanox almost 7 years ago to focus and develop future silicon, or future InfiniBand silicon. And after a few years in working in engineering, I moved to the dark side of engineering, becoming part of the marketing group. So since I have only 10 minutes here, and there's too many slides, I tried to figure out how can I reduce the number of slides I'm going to talk about. So earlier in the morning, there was someone says here that you cannot spell HPC without saying InfiniBand. So that's conclude my slides. I try to focus more here on technology and futures and slides that have cool videos. So basically, Mellanox, at Mellanox, we're looking on InfiniBand as a competitive advantage. When you look on clusters and high-performance computings, you want stuff to run faster. You want to be able to have more jobs per day, increase productivity. And that's the key messages that we keep inside when we come and design products and future InfiniBand products. So all of us know that InfiniBand connects the most powerful clusters, but it's not only the most powerful clusters. You can see installations from large ones and small ones, and that's supposed to be the video. Or supposed to be. Okay, it runs on my laptop. So looking at the market, looking at the HPC market, there are several several demands that are driving future development of future solutions. One of them is multi-core CPUs, which you can run more applications per server. There are more demands from the I/O because each CPU has its own requirements from network. Then there is the latency race. More applications demands real-time response. People want to connect the storage part into the clusters as well. And in overall, there is a demand for more I/O capacity. So looking at that, that's what drove us to design ConnectX, which is the latest InfiniBand and 10 gigabit Ethernet adapter in the same device. So it's a single chip that runs both InfiniBand and 10 gigabit Ethernet. There are 2 ports there, so you can have 2 of them running InfiniBand or 2 of them running 10 gigabit Ethernet or 1 running each. We focus on the InfiniBand as the highest performance interconnect for choice, providing 20 gigabit per second, and also support for 40 gigabit per second, which we do expect to see in the market in the later part of 2008. So that's on the bandwidth side. On the latency, we were looking to reduce the latency into numbers, much lower numbers that people were seeing before. So ConnectX providing 1 microsecond latency for applications. That's on the InfiniBand side. On the 10 gigabit Ethernet side, we're also focusing on performance, ability to provide high throughput with low latency. And the reason that we have added 10 gigabit Ethernet into the same NIC is to provide the ability to go to Ethernet storage or to build the ability to connect to the outside world in much easier ways. ConnectX was also multi-price for CPU, multi-core CPU. So when you typically look on low-level benchmarks, people look on the latency of one core sending data to another core in the second system. The question won't happen when you have all 8 or 16 cores in the system sending those jobs. What's going to happen to the latency? So that's something that we were focusing on. So that's some slides on ConnectX performance. On the left side, you can see the latency of 1 microsecond latency. ConnectX also support PCIe Gen 2. So there is a slight latency decrease with moving to PCIe Gen 2 systems. And on the bandwidth side, again, this graph showing the bandwidth of InfiniBand DDR on PCIe Gen 1, PCIe Gen 2 systems. That's the multi-core optimization that I was referring to. Looking on multi-core system, in this case, when you have 8 cores in a system and you're running 8 jobs in parallel, you want each of the jobs to see the same lowest latency. as having one single job. So look at the latency on MPI multi-core, you see that the line is very straight. Tomorrow we're going to announce the next switch silicon, which is going to be the first generation of the InfiniBand switch. So please keep the data for you till tomorrow. The architecture of the next generation switch was designed to support 36 ports, each one of them running 40 gigabit per second. And you can configure the switch to have 12 ports, each one running 120 gigabit per second. So the 40 gigabit per second probably going to use between switches and the servers or the storage, and then 120 gigabits per second between switches. Another optimization is reducing the latency of the switch from 200 nanoseconds in SDR and 140 nanoseconds in DDR to 60 nanoseconds for a switch hop. Some two other key features that we added. Congestion management or congestion control, as Andy talked before. But also we added adaptive routing, which is another ability into the InfiniBand side. So this is just comparing previous generations and the new generation of switch for switch speed, latency, and scale. But I just want to focus on two slides here. So looking on a network that can fit large-scale clusters, there is a need to answer four things. One of them is what you do when you have balanced random network streaming, which means that you have one-to-one networking, but it's a random streaming. So in order to increase the efficiency in that case, what you want to have is the ability of adaptive routings. Meaning if there is one port that is congested or there is full more than others, you want to steer the traffic to other ports. Another case is a balanced no-network streaming. Again, it's one-to-one networking, but in that case, the streaming is known. For example, doing shift patterns in MPI. So for that case, static routing is going to give you the best performance results. So you won't have the ability to choose between dynamic and static. Another problem is when you have unbalanced network streaming. It's the case when you have many sending traffic to one node. In this case, nothing going to help you. Not dynamic or static routing going to help you. The only thing that's going to help you is doing congestion control in order to increase the efficiency of the network. And then at the end, you want faster network streaming propagation. It's bigger the pipe, more data you can send, and utilize the fabric much better. So here are two results. One of them is the congestion control results that Andy showed before. This time it's in color. The first one is before doing congestion control in a simulation that was done, in that case by IBM. And then after using InfiniBand congestion control and seeing the increase of the efficient bandwidth in the network. The second one is the dynamic routing. We did these simulations looking at what the new features of dynamic routing in InfiniBand is going to provide to application. And here you see before adaptive routings and after adaptive routings, how you can continue in managing the highest throughput throughout the network. That's my summary slides. I'm good on time. So InfiniBand is market-wide adoptions. ConnectX already being used by more than 1,000 node clusters. And if nothing surprisingly going to happen, we're probably going to see a couple of those in the top 5 of the top 500 list, which is going to be published tomorrow. The first generation ConnectX was focusing on multi-core environments, providing performance features and performance abilities. And then the switch architectures that's going to be announced tomorrow, moving from 20 gigabit per second to 40 and 120 between switch links, driving the trends in the market or the key needs in the market, which is cluster states, low latency, high consolidations, and multi-core CPU environments. Thank you very much.
Thank you so much. Any questions from the audience? One question.
So you're announcing, I guess, a one-use switch. Is that the only announcement tomorrow for the next few months or a year, or are you announcing more than that, like a lot larger switches?
So So we are announcing the switch silicon. Mellanox are not building the switch boxes. For that, there are other vendors, Voltaire and Sun, are building the switch boxes. But you question if there are other announcements of silicon products from Mellanox, or? Forget it then. Okay. But for your questions, just so we're announcing the switch, and we do expect to see in the second half of 2008 to see switches from a 1U36 port to two tier of 648 ports, which is equivalent to today 288 ports. So that's something that we do expect to see, and we do work with our partners and customers to make it happen.
Yeah, I have a question about the Mellanox HCAs. With the earlier HCAs, the DDR ones, we had seen 1.5 times the SDR rate instead of 2.0. I guess that was more because of the PCIe bus, I was told. Does the ConnectX card rectify that? So if you look on the maximum bandwidth, the SDR could reach 1 gigabyte per second, and the DDR could reach 1.5 gigabyte per second. The reason it's not because InfiniBand couldn't reach the 2 is because the PCI Express chipsets on PCI Express by 8 were limiting the throughput from the memory to the I/O for 1.5 gigabyte per second. PCI Express Gen 2 breaks that limit. So when you're using PCI Express Gen 2 systems on InfiniBand DDR, you're going to reach the 2 gigabyte per second. Now again, moving to InfiniBand QDR, which is going to be enabled by the new switch, then the PCI Express Gen 2 will start to be the limit again. So with InfiniBand QDR, you will not be able to reach the 4 gigabyte per second, but you will probably going to be able to reach the 3.3, 3.5 gigabyte per second. But then futures hold us PCI Express Gen 3, so all this is going to continue.